Okay, now we have come now into the next part. Okay, we talk about moments having a clockwise, having two different directions, clockwise moments, anti-clockwise moments. Okay, now let's go in deeper. Let's dig deeper. Let's look at some examples. I think we have all played the seesaw before. Okay, you'll see one fat guy here, and then one skinny person here. There's a skinny person sitting down, one fat guy sitting down, and it's amazing how your seesaw can actually balance. How does it balance? That's the question. Okay, obviously if this chapter is on moments, this balancing has to be in regards to the moments. So in actual fact, when you are balancing the two person, you're not balancing their weight. Okay, take note, you are not balancing their weights. What you're actually trying to balance is the moments. So in short, to balance a lever, okay, the following rule must be applied. Talk about anti-clockwise moment, clockwise moments. To balance this, okay, take note this key here, balance the lever. To balance the lever, what must be considered? Is this thing over here. It must obey this thing called the principle of moments. So it states that when a body is balanced or at equilibrium, in equilibrium, okay, the sum of clockwise moments, we're talking about the sum, okay, so it's adding up all the various clockwise moments. The sum of the clockwise moment must be equal, okay, must be equal to the sum of the anti-clockwise moments, about the same pivot. So you can think of it as there's four parts to this. One is a body in equilibrium. This is the first part. Okay, you talk about the second part being the sum of clockwise moments. Okay, this is the second part. Okay, must be, what must it do? It must be equal to the sum of anti-clockwise moments. Okay, you can see it's a bit dark there. So take note, it must be equal to the sum of anti-clockwise moments. So this is the third part. And it's what? The last thing here? About the same pivot. Okay, about the same pivot. So there's four parts to this. So the principle of moment states that when a body is in equilibrium, so which means that it's balanced, the sum of clockwise moments is equal to the sum of anti-clockwise moments, about the same pivot. People tend to miss out this last part over here. So always remember there's always one last part after saying that the moments are equal. So the sum, okay, in this case F1 D1 equals to F2 D2. In actual fact, you can plus more. You can plus more things over here. This is only for a very simple one. So let's try an example. A uniform plank is pivoted at its center. Given that the plank is 5 meters long, so we know that this plank here is 5 meters long. Okay. How should a 15 Newton ball be positioned if the 12 Newton ball is positioned at one end of the plank? So if it's at one end, we know that the distance here to here is 2.5 meters. Now the question is, how far should the 15 Newton ball be placed? Okay, how far here? What is the value of x? So how do we go about doing the question? Take note, if you want to balance, okay, you can see here. Okay, should we position? Okay, to balance it, to balance it. Okay, so this key here is about balancing. So when you talk about balancing, you must apply the principle of moments. Okay, let me highlight. Okay, principle of moments. So now, how to apply the principle of moments, assuming that we do not know the distance. Okay, so we say that 2.5 meters we know, okay, 12 newtons away. So this force produces an anti-clockwise moment. This force over here instead produces a clockwise moment. So you can see this 12 Newton produces anti-clockwise moment. This 15 Newton produces a clockwise moment. So there's a chance because two different type of moments, they may be able to cancel out. So how do they cancel out? Okay, it's by going against each other. So what's the distance to be placed so that they cancel each other just nice in the right amount? So we say that the anti-clockwise moment in this case is 12 times 2.5. This is actually F multiplied by D. F1, D1 multiplied each other is equals to F2 times D2. Okay, so the F2 is 15 newtons. The D is question mark. We do not know. Okay, so by doing some simple maths, you realize, oh, D should be placed 2 meters away from the pivot. So therefore we conclude that the ball should be positioned 2 meters away from the pivot. Okay, so in the end, we will put our force here. Okay, somewhere around this point, and D is 2 meters. Okay, so this is with regards to the usage of principle of moments. Okay, so just take note of this. More questions are to come. Okay, so just take note, you have some worksheets. Please practice the principle of moments. Okay, these questions are bound to come out most of the time. When you go up to upper sec, you will delve more into this also. So please remember about it.